This is another one which I already, one other point with the delegating your tokens or your Tez is it's non-custodial. So you're not basically handing over your Tez to the baker. You're only like, almost like setting up a link to say that, okay, my tokens are still with me, but I'm kind of like giving you the right to use it for baking purposes. That's the only, and it's impossible for someone to steal your coins as such. As long as you hold on to your private key, it's completely secure. And then if you are, there is a very detailed technical explanation on this link if you are interested. And this will be probably more makes more sense for someone who wants to like actually fire up a node and like for developers. When you download the Tezos software and start it up, there are various components of the software itself. Very high level architecture is you have the Tezos node, which is the heart of the application, which runs the which responsibility is to like start up and then sync to the network and keep the blocks in sync with the network. And there is a command line client to interact with that node. There is also an admin client which you use for the baking, the endorsing, all these operations which are admin operations. There's another client, but it's all packaged in one software, but it's all broken up architecturally. You can think of it as like the libraries all are in one repository, but they all like work independently. And then there's components for actually like baking, and the endorsing, and the accuser is this daemon which constantly runs, trying to find blocks which might have been tampered with. That's how it keeps the system more secure. Yeah.
So baker, endorser, accuser, the rewards are the same, the value?
No, for baker, when you bake, you get 16 Tez, and the endorser gets 2.
It's only 2.
Why are there no rewards for the accuser? So the accuser finds a tamper block.
So accuser does have a reward, because when the accuser succeeds in finding an invalid block someone has baked, they get penalized. That penalized money gets distributed to the endorser, not the endorsers. I don't know the percentage, but the accuser gets some part of that money.
The accuser finds something and then an endorser confirms, yes, this is used.
Right. Yeah.
The accuser gets
Accuser gets it, and some Tez is also burnt.
Oh, I see.
Yeah.
But this verification and validation between these actors is automated, right?
Correct. Everything is automated. There's like no one like actually sitting and doing any like actual work. Yeah, it's completely automated.
Okay.
And then I wanted to just quickly go over like if you were to build smart contracts in the Tezos platform, like Michelson is the language, which is like a low-level language, almost close to assembly, maybe not, but this is the language. But really, like no one, I do not think anyone would actually like build robust applications on the Michelson language, unless you are like very proficient in low-level assembly code. I don't think anyone would do. However, there are higher-level languages which compile down to the Michelson. Those are what will be used. There's one called Liquidity, which is this code, which looks very similar to OCaml code. It's a really cool language. It's fun to write this code. And then there's another language I think called Phi. Andrews, I think he's working on. He's the creator of Tezbox, and he's done a lot of things in the Tezos community. And for Liquidity, there is an online IDE. You could just go and write and deploy, and in fact, they also allow you to just deploy your code too. So
So when you say compiles, that means you can just type something out in liquidity like you see here,
Yep.
put it into the compiler, and it will just convert it into making some code.
It spits out this. Like that online IDE is like, it's pretty cool. Like as you're like typing and compiling, it spits out this code. You can see. Like when you're applying formal verification, like this is what you're applying the formal verification to, not the higher level language. It's this which you're applying it to. And then I wanted to just talk few minutes about the accounts, which is useful for both technical and non-technical people. There are two types of accounts in Tezos. Accounts in the sense like addresses. One is the address which starts with TZ1, which is the implicit account. So for example, if you go back here, you can see this Tezos community has this address where people delegate to. This is an implicit account. And if you have any other cryptocurrency, if you're played with, like there's a Bitcoin or the Ethereum, whatever, like the idea is the same. You have a pair of public and private key, and this account is derived from the combination of the public and private key. This is a public. You take a public key, and then each blockchain has its own way of generating this address from the public key. The private key is something which you hold on to and you never reveal. So that is the implicit account. And then there is another account called the originated accounts in Tezos, which starts with KT1. And you can think of this account as really a smart contract. This is the account which you will need to delegate your funds to a delegate. You cannot delegate directly from this account. You can use this implicit account to send and receive money, to receive Tez. But if you want to delegate, then you have to use KT1 account. And the way you do that is like pretty much all of the wallets support these accounts. Every wallet has this functionality to go and create this KT1 account. It's pretty much a click of a button, and then it generates this account. There is some Tez you have to pay in fees, because this is essentially a smart contract you're deploying to the network. So you create this account, and you can fund this account and delegate it. It has a few fields to store all the metadata about what is in this account, but essentially those are the two main accounts which pretty much everyone should know. If you own Tez, you should know that these are the two types of accounts or addresses.
This one, is it one-to-one or one-to-many originated accounts you can create?
One-to-many. Yeah. Well, you can. The way to think about it is not even like one-to-one or one-to-many. It's not related to this at all. So there is no link between these two accounts. You have a wallet. Your wallet can hold as many addresses as you want. So you can generate as many KT1 addresses as you want. So there is no like link between these two.
But there is manager, right? Manager is the link.
The manager is so your manager is the private key of the account. It's the private key of this account.
Yeah.
Okay. And this is, if anyone is like familiar with Ethereum, it's a similar concept here. You have to pay the network for doing any kind of processing or deploying your smart contracts or interacting with it, because your transactions need to be executed by nodes, and it costs resources to do it. So you have to pay fees, and the fees is paid in Tez, and it's called the gas fees. So that's the gas fees, and then there's a gas limit, which is you cannot just try to execute some extremely resource-intensive code, so that they set a limit because they want to make sure that the transaction actually completes within a certain time. So that's the gas limit. The one other thing which Tezos does, which Ethereum doesn't do yet, is to store your data in the blockchain. you have to pay fees for it because it again costs resources. Ethereum, it's free right now, but there are proposals to do to charge rent. But in Tezos, you actually now have to pay storage fees, and there is also a limit.
Who collects them?
Sorry?
Who collects the fees?
The network gets it, which means when you bake, you are not only getting 16 Tez in rewards, but you are also getting these fees.
But the fees goes to a certain entity or a certain wallet?
The baker who includes your transaction, so you want to execute your transaction, you pay the fees. That transaction is in a block which someone bakes or someone includes, that they're the one who get it.
So
Yeah.
there's like the foundation is getting.
No, it's a decentralized entity, so there's no like foundation has nothing to do with the thing. So
a few questions on gas.
Yeah.
I know originally the network allowed you to transact with zero gas fees. Is that changed?
yeah, you cannot do any more with zero fees.
Secondly, I remember in like one of these wallets, let's say Tezbox, if you were sending from the manager account into a KT1 account, you couldn't leave zero left in the manager account. It had to be enough to cover the fee.
Yes,
Is that still the case? Or
it is still the case because yesterday I tried and it failed with zero.
This much changed they just updated the interface, so they actually have a preset gas, like low,
Medium and high.
So you can so according to how fast you would like to transmit that transaction. So
But-
you will not miss any.
They used to allow with zero, not anymore, because I tried it and it failed. You do need to have Tez in it for it to do it.
I wonder how that's going to affect baking rewards. If there's network becomes so heavily used, you're going to have so many fees generated, you might have more rewards and fees than you do in actual baking rewards.
Yeah, I think we're still a long way from that.
They charge that to you, but right now I think most of the bakers, they absorb the fees. But they said later on maybe they will decide that they will be charged to your reward. It will be deducted, but it's very minimal.
That could be a value proposition itself.
And then there are mainly three networks in Tezos. The main net, which is the production system, which everyone uses, and all the Tez there is real. It has real value. And then AlphaNet is really for developers to tinker with, build applications, test it. It's like your test or staging system if you're a developer. That's called the AlphaNet. And there is a faucet where you can go get Tez for testing. It's fake Tez. And then there is another called the ZeroNet, which really no one needs to except the core developers. No one really uses it because it's bleeding edge. There's bugs. It's under active development. Protocol is tested there. So that's another network. So those are three main networks which usually developers care about: mainnet and the AlphaNet.
So right now the current build for main net and AlphaNet is equal, or is there?
No, they're not the same.
So if you try it in AlphaNet and then later on you have to deploy it in the mainnet, you don't know if it's the code, the build is the same.
Oh no, you're guaranteed it will behave the same way. It's just this is for testing purposes, so you don't have to spend real money to test your applications and stuff. At a very high level, that's all I had. If you guys have any questions.
So when you present a proposal for a feature, it says that it's first promoted to the testnet.
Yeah.
So is the testnet is the actual testnet, and it's linked to the actual protocol of the mainnet?
Yeah, it's the same code which runs on both the networks.
Yeah, so like normally if you think about like in Ethereum, they'll have a testnet, we'll just set it up, and then if you want to create a new testnet, you can just create one whenever, right?
Yeah.
But if there's a protocol that's been added to the mainnet, it will also be it'll update the testnet.
It's always the other way around. If the protocol is getting updated, it's always going to be first on the AlphaNet, or the AlphaNet, and only then it goes up. It's never going to be the other way around.
There's like some link between them.
Yeah, it's not the link, it's the code in the repository which gets deployed to the network. You're basically asking everyone who's running the nodes to like upgrade their systems, basically. So let's say there's a new protocol which gets pushed, the code pushed to the repository, and then everyone who's running AlphaNet network, like I run an AlphaNet because for my development, so I update my code, I update my software, so I'm running the new protocol, right? And then once it runs for a few months, everyone is like happy with it, then you send out another note saying, hey, everyone go and update your software with the latest version which has the latest protocol.
So typically that would be like, if you think about like, I mean, just Bitcoin, I guess, right? So that's how Bitcoin would work, where everyone just kind of votes by updating their software, right?
Correct.
And then if you have 100% consensus, then it's updated to the new version.
Yep.
But like, I guess what I haven't figured out, and I wondered if you could help, is like, how does the actual on-chain governance impact, like, what's the link between the on-chain governance and your actual code base? Other than just the voting is done on-chain, and then everybody goes and updates to, 1.5 or whatever.
So in the code itself, it can host, there's a switch to update to the new protocol. So it's not like someone has to go and merge that code, your protocol, and then actually ask everyone else to update it. That part is like automated. So they have this whole architecture of like this Tezos shell, which hosts like this code with the updates, and which gets applied based on the how much votes are received. Based on the number of votes received, it automatically turns on. And whenever someone pulls the latest software, it gets the protocol, the latest protocol.
Okay.
So if you get the code for the main right? So you can just configure it, either use the AlphaNet or you have to have a separate GitLab code for that.
It's all in the same repository, it's just a different branch. When you are actually like checking out, you just say git checkout -b AlphaNet, which gives you the AlphaNet branch versus the mainnet branch. The code is all in the same repository but different branches.
Sorry, I'm still confused on the self-amending part. The protocol is self-amending. Why do people have to update the software?
To let's say there is code in the repository, and that is the active code. I'm like, as a baker, or I'm running the node. Tomorrow you are going to propose a change to the code. Eventually for me to use that code, I need to upgrade it with the latest code, right?
Is it that there are two types of changes? There's like a protocol change that would require an upgrade, and there's a code change that does require.
Yes, because for example, yeah, that's a good question. For example, a couple weeks ago, they had a critical bug, which the core developers actually like patched. And it was like on Slack channels, they were like tweeting, everyone were like basically like telling everyone like, you need to upgrade if you want to still be baking. So that is a change, had nothing to do with amendment process, nothing. It was like a patch which the core developers pushed.
All right, so when things are running well, everything's stable, ideally you can almost never upgrade the software.
Yep, right. And in like Ethereum or Bitcoin, when there's like a hard fork, if you don't upgrade, you're kind of split and you're on your own chain, which is invalid. The idea here is to never get into that situation.
Can you explain a little more about that situation you touched on, that 2 to 3 week ago situation where the developers came in and did the hard patch?
So there was, I'll try. So what happened was 3 weeks ago, there was one node which was a baker which was misbehaving, that node, because of this bug. What happened was it was stopping from blocks being actually added to the chain. So there were, for a few hours, there were no more blocks being added to the chain. So they had to push the fix and ask everyone to update it. So the the node which was not working correctly could actually be not penalized, but it could like, the lottery could be moved to the next one. So that part wasn't happening. I don't think I'm doing a good job explaining, but basically it was stuck. There were no new blocks being created for a few hours. So the only way for them to do was to like patch and everyone to upgrade.
So you could send a transaction during that period, it would just remain unconfirmed.
It was remain unconfirmed for a few hours, yep.
So when it came back online, the first block must have had enormous amount of transactions in it.
Since there is a block limit, you can't really package all of the transaction. It's still, there can only be so many transactions. It did catch up, but yeah, there were enough transactions pending. But I should go back and look into that in more detail. There was a good article on, there was a good thread on Reddit. Someone had like very well explained, someone from Cryptonomic, I think. I should find that. Just search on like Reddit, Tezos Reddit, I think you'll find it. There was a very good explanation there.
But the upcoming proposal for the amendment, is that the ZK Snarks? Or ZK from Mr.
No, it is ZK Snark, yeah. Yeah. I think the code is already in the repository actually.
So is it going to vote or is it just going to be?
No, I think it's going for vote.
Okay.
Yeah, and pretty sure it's going to go through.
Yeah.
So it's a good thing, so.
And it's Obsidian Systems that just came out with the announcement that they're going to have a voting interface on the ledger.
Not sure.
Yeah,
But, okay.
It was just broken the last day or two about
Oh, okay.
that. Because otherwise, how do you vote at this point?
Correct, yeah. Through the command line.
Command line.
Yeah.
Good luck getting 60%. Or
Yeah,
80%.
yeah. So. Cool. All right. Thank you, guys.
Hello everyone, I just want to give a big thank you to all of you who attended Tezos Boston Meetup 4 and to anyone that's attended any of the Tezos Boston Meetup events. Thank you so much. It's been a great 2018. I'm very excited for what 2019 has to bring. Thank you again to Mahesh from Zastrin Labs for the awesome presentation, and thank you to the entire Crypto Lively crew for helping host the event. Until next time guys, take care.